All right, we are going to start to take a look at refractions through lenses. Lenses are very important. Where do we see lenses? Oh, first, what is a lens? A lens is just a piece of shaped glass or plastic, sapphire, anything that's clear really, that bends the light a desired amount. Right, that's all it is. And they usually have curved surfaces. So here's a typical lens. It could look like this. It's just glass. This is from the side, from the front. It would look just like a circle. Lenses can have a shape like that. Lenses can have a shape like this. Lenses can have shapes like this. Lenses can fit together almost. So you have all these different shapes, and when light hits the lens, it bends some way. Now, technically, when light hits the lens, it bends when it hits the first edge, the first barrier, and then it refracts inside the lens. Then when it hits the second barrier, it refracts a different direction. So you actually get this two refractions. One at each barrier. Right? Where do you see lenses? Well, people with glasses have lenses. Right? I am nearsighted. There's my glasses lens. You can see how they refract the light around. You can see how it bends everything. So yeah, I'm nearsighted, so my glasses have a certain shape. They're shaped a little bit like this. Far-sighted people who can see better far but not close have different shaped lenses. So glasses have lenses. Cameras have lenses. That little camera inside your iPhone has 5 or 6 or 7 lenses in it. They're all stacked together, really close together. Different shapes so that as the light passes through, they can make the light do exactly what they want it. Get it from outside the phone onto the sensor. Magnifying glasses are lenses. What else are lenses? Well, you've got telescopes. Binoculars have lenses. Binoculars usually have lenses and prisms in them. Microscopes. Some lights often have lenses. So these are all different ways to shape light, to get light to move to where you want it. There's cool things called lenticular lenses. You should look them up, see what they are. So all these different kinds of lenses. Now we've got two types of lenses. A concave lens, right? Similar to a mirror, concave lens bends inward like this. This is a double concave. So we call this one concave, right? Because both sides of the lens are important. So here's a concave. This side's concave, this side's concave. This would be a diverging lens. When the light hits it, it will spread the light out. All right, so the exact opposite of a concave lens is a convex, so sticking out convex lens. So this is a convex, right? Convex means sticking out. Convex, convex. This is a converging. When the light hits it, it goes in. They converge to the focal point. Convex, convex. Of course, now you can have any combination of these. You can have concave, convex. So a concave, convex might look like this. There's the concave side, and then there's the convex side. Right, concave and convex. All of these lenses are just there to do what you want, to get light to go where you want it to go. All right, so what we're going to do now is we're going to take a look at drawing an image as seen through a convex lens. So convex is a converging lens. We have our lens right here. Now I've drawn the lens on, but what's important here is this midline is the middle of the lens. That's where we're going to do our refracting. Now, even though when light hits the lens, it kind of refracts twice, right? For a thin lens, we can just kind of ignore it. So this works for thin lenses. We can just kind of ignore the fact that it refracts twice and just have a bend at the center. Again, we've got our midline here. We've got our focal point here and our focal point here. Our objects on this side. And we're going to be figuring out our location of our image, the orientation of our image, the size of our image, the type of our image. We're going to be figuring out all these things again. Right, and the rules are very similar to how the rules before. So our first ray runs parallel to the midline. Hits the middle of our lens. It's a thin lens, so we use the middle. Then it refracts down through the focus. Continues on. That's our first ray. This is ray 1. Parallel, then through focus. Then to the focus. Ray number 2. Right, we have to draw 2 rays. I hope it fits. Through the focus first. Then it hits the midline. And then it bends out parallel. So focus first, then parallel to midline. Where's our image located? Right over here. Now, I'm going to need to extend my midline. Here's my image. Right here. Image. Okay, so we can talk about this image now. Its location. Well, we have to see how far from the middle of the lens it is. I've got it at 8.5 centimeters. 8.5 centimeters on the other side of this. So it's going to be negative. Every year I teach this, I always get confused with the negatives and positives of the location. I should just learn it once, and that's all. Our orientation, well, it's inverted. Our size, well, this guy here is negative 2.6 centimeters. Negative 2.6 centimeters. Now, we can figure out our magnification, right? Our magnification is we take our negative 2.6 and we divide it by our positive 2. Divided by plus 2. We get a magnification of negative 1.3 or negative 130%. The negative tells us that it's inverted. The 130% tells us that it's bigger. Right? If it's smaller, if it's shrunk, this would be less than 130%. Now the type. We have two rays converging. That means this is going to be a real image. So converging rays make real images. As long as the image is on the other side of the lens, it's going to be real. Right? That's the opposite to mirrors. Now this formula works again. This little formula here works again for this. So what we're going to do is we're going to try out this formula. See what happens. So 1 over my focal length is equal to 1 over this distance to my object plus 1 over the distance to my image. And my object is 6 centimeters away, so 1 over my focal length is equal to 1 over 6 plus 1 over negative 8.5. See if this works out. Gets us something close. So I go to my calculator. 27% battery today. Not bad. Which calculator do I want? I just go to TIDIG. So I do 1 divided by 6 plus 1 divided by 8.5 negative equals then I do 1 divided by that answer, and I'm going to get a stupid number, 20.4. That's incorrect. Haha, isn't that wrong? This is a positive then. Let's try that out. Let's change that from a negative to a positive. Yeah. It gives me, so I change this from a negative to a positive. I do that in my calculator. So our location is plus 8.5 over here. And I get a location of 3.5 centimeters to my focus. And I look here, and it's pretty darn close to 3.5 centimeters. So real image, positive location. Virtual image, bet you it's going to be a negative location, but we're just dealing with a real image. All right, so there we go. Not too bad. Outside the focus, this all happened. This is makes pretty good sense to you. Parallel first, through the focus second, through the focus first, parallel second. What happens here? We get this object inside the focus. Well, let's follow the rules first. All right, so first one, parallel. Through the focus. That's ray 1. Ray 2. Now, run into a little issue here. Ray 2, we actually go like this, and this is terrible because this doesn't work because this is way too big. All right. I hope you didn't draw that ray. Because this won't work. Because the next ray we have to go through like this, and then it goes way up here, and then we draw a parallel like that. And then we got to backtrace everything to the right location. And that's just not going to work too well on this page. All right, so let's do something to make this work. We're going to make a much smaller one much closer. So there's my object right there. Going to make a smaller object closer to the lens. Again, so I'm not going to use blue again. I'll use red and pink. So my first ray, parallel through the focus. Our second ray, we start at the focus, we go across like this. It hits, then it's going to refract parallel. Now what's the problem here? These are diverging rays, right? They're moving apart. Diverging means moving apart. So where does our image happen? This is where we have to do the backtrace thing. So we always backtrace the refracted ray. So we take this guy, and I need to use pink for this. We're going to backtrace it. I'll put dashed lines. We just go backwards. Then we take this guy right here, and we backtrace this guy as well. And look at that, it's right there. So right about there is the location of my image. All right, so let's write the lost. Okay, so we drew our first ray parallel through the focus. We drew our second ray from the focus to the lens, then parallel. But because these were diverging rays, we had to backtrace our refracted rays. And where those, we got our image. Because we're backtracing, we get a virtual image. Size. Well, this image is 1.6 centimeters. Now we compare that to our object, which was 1 centimeter. Means our magnification is 160%. Our image is bigger. Our orientation is upright. And our location is, well, we measure it. What do we got here? 2.5. Pretty sure it's negative 2.6 this time, centimeters. Pretty sure. Our object is located at 1.5. Okay, we're going to try this out. We're going to see if my conjecture was right about this being a negative because it's virtual. So we go. 1 over f equals 1 over d sub o plus 1 over d sub I. 1 over f is equal to 1 over 1.5 for our object. Object's always positive. 1 over negative 2.6. Let's see what happens here. 1.5. And 1 over 2.6 negative. That gives me a focal length of 3.5454, or just 3.5 centimeters, which, as we showed before, was pretty darn close. So our object always has a positive. Object is always positive. Virtual images have negative distances. Real images have positive distances. All right, so that's how to do a ray diagram for a convex lens, and then how to use that formula for it. In the next video, We'll look at ray diagrams for diverging lenses or concave lenses. All right, and thank you for watching. If you have any questions or just some general annoyance about me not knowing whether things are positive or negative, you can talk to me about that. Thank you for watching.